Hello and welcome back to Math 055. This is a video for section 7.5, and we're going to be talking about expressions containing several radical terms. And what we're going to be doing is, adding and subtracting radical expressions, okay? And what we're looking for are these things called like radicals, okay, where the index or the root has to be the same, and the radicand has to be the same. Variables express, okay, yeah. Let's come over here and let's talk about combining like terms. It's very similar to this idea. So combining like terms. Okay, so what we've been doing for a while is, you have something like this where you take like 2x plus 3x. Okay, these are like terms because they have the same variable raised to the same power. Okay. Where if I were to add these together, it would give me 5x, okay? Similarly, let's take like, say, 4y squared minus 3y, let's do minus 2y squared, okay? Because we have the same variable raised to the same power, we can combine these, okay? So 4 minus 2 would give me 2, so equals 2y squared, okay? So that's, the idea. We're combining like terms, okay? Now, like radicals, all right, let me just give you an example of like radicals. Okay, so like radicals, would be something like this. Let's say I have like, say the square root of 2 plus 3 square root of 2, okay? Because I have the same radical, okay, the index is the same, meaning they're both square roots, and what's underneath the square roots is the same, then this would give me 4 square root of 2. Okay, this is 1 times the square root of 2, so 1 plus 3. Same idea as combining like terms, it's just like radicals. All right, let's look at something a little bit different. Okay, let's look at, say, like 7 square root of, let's not do square root, let's do the cube root of 3x plus 8 times the cube root of 3x. Because we have the same radical, because we both have cube root of 3x and cube root of 3x, we can combine the numbers up front. Okay, and this would give me 15 times the cube root of 3x. Okay, so that's the idea. If we know that, then everything else is easy. All right, but they're not always as easy. Okay, the first one's pretty easy. All right, 7 root 2 minus 5 root 2, that's just going to give me 2 root 2. 7 minus 5, keep square root of 2. Okay, think of, 7x minus 5x. Notice how we would get 2x out of that. All right, same idea. All right, so if you know how to do this, apply the same concept to this, and it's pretty easy. Okay? Okay, now let's look at part B. Now, part B is a little bit trickier because we don't have like radicals. However, we can simplify this. Okay, let's simplify that so determine if we can get like radicals. So let me split this up and let me do the square root of 9 times the square root of x plus the square root of 49 times the square root of x, and then minus 9 times the square root of x. Okay, so the square root of 9, that's just going to give me 3. Okay, so I can take the square root of that. So I get 3 times the square root of x plus square root of 49. Now the square root of 49 is 7 times the square root of x. Oh, look at that. Look, guys, I've got like radicals. Oh, look! I've got another one over here. Okay, so now I've got minus 9 times the square root of x. So all 3 of these terms have like radicals. That's pretty sweet. Okay, so now what I can do is I can combine them. All right, so if I combine these two, so 3 square root of x plus 7 square root of x gives me 10 square root of x, and then minus 9 square root of x. Now if I do 10 square root of x minus 9 square root of x, that gives me 1 square root of x. Now 1 times the square root of x is just the square root of x. Okay, look at that. Isn't that nice? That's nice. All right, take a look at the second one. All right. Now what I have over here, it appears as though we have some form of like term, okay? And what I'm going to do is simplify each of these terms in this problem. All right, so let's come over here and let's do this. Let's simplify these first, okay, and then go from there. So let me split these up first. All right, so I'm going to rewrite this as 2 times the square root of 40 times the square root of x to the 5th minus 3 times the square root of 90 times the square root of x to the 5th, and then plus 5 times the square root of 160 times the square root of x to the 5th. Now, okay, so let's just do that. Now, let's split these up. All right, let's think about perfect squares, numbers that we can take the square root of that go into 40, 90, and 160. Okay, so on this problem, what I want to do is I'm going to rewrite it like this. I'm going to do 2 times the square root of 4 times the square root of 10. Okay, 4 is a perfect square. You can't take the square root of 10. Now, when I'm doing square root of x to the 5th, let's split this up into the square root of x to the 4th times the square root of x. Okay, if I were to combine these two, I would get square root of x to the 5th. So I'm just rewriting it. Okay, now I'm going to subtract 3 times, let's do the same thing, square root of 9 times the square root of 10 times square root of x to the 4th times the square root of x. Okay, and then over here I'm going to do plus 5 times the square root of 16 times the square root of 10 times, and then let's do square root of x to the 4th times the square root of x. Okay, so now, all right, what I want to do is go through and simplify what I can. All right, so let's do 2 times the square root of 4 is going to give me just 2, okay, times the square root of 10. Now I can take the square root of x to the 4th. 4 divided by 2 is going to give me x squared. So times x squared times the square root of x, okay, minus 3. Now the square root of 9 is 3. And then we should get the same thing, okay, square root of 10 times x squared times the square root of x. Okay, now over on this right side I've got 5, so plus 5 times 4 times the square root of 10 times x squared times the square root of x. Now what I want to do is kind of reorder everything. Okay, and I can make this a little bit bigger. If I do 2 times 2 times x squared, that's going to give me 4x squared times the square root of 10x. Okay, I can combine these two. Minus 9x squared times the square root of 10x. Okay, and then plus 20x squared times the square root of 10x. So, all right, what I have is these are all like terms. Okay, they have like radicals and like terms. Now, even though you've got an x squared out here, that's okay because all the other terms have x squared. All the terms have the square root of 10x. Okay, and that's what I'm looking for. All right, so if I do 4 minus 9, that's going to give me negative 5x squared times the square root of 10x plus 20x squared times the square root of 10x. So now if I take negative 5x squared plus 20x squared, that's going to give me positive 15x squared times the square root of 10x. That one was a lot of steps, okay? Make sure you guys write small. I apologize that there's not a ton of room on here, but that's the idea, okay? All right, make sure you're following through step by step. How did I go from one step to the next? Make sure you're using the pause and play button to help you with this. Okay, next one, what I want to do is think about numbers here that I can take the cube root of, okay? So if I wanted to combine these, now the cube root of 16, I can't evaluate that. But what I want to do is this. I want to do the cube root, let me split this up into the cube root of 8 times the cube root of 2. Okay? Now 54, 8 doesn't actually go into 54. All right, so there's a problem with that. So I'm going to do minus 5 times the cube root of, I know 27 does, times the cube root of 2. Oh, check that out. Okay. And now what I've got is I've got this, plus 2 times the cube root. Now I can split up 40 into the cube root of 8 times the cube root of 5. Okay. Now, here's what I'm going to do. I'm going to see what I can evaluate here. So if I take the cube root of 8, that's going to be 2. So 2 times the cube root of 2 minus 5 times, now the cube root of 27 is 3. But this is 3 times the cube root of 2. Notice how both of these terms have a cube root of 2. Plus 2 times cube root of 8 is 2, and I'm left with the cube root of 5. All right, now that's okay. All right, now let's simplify this. Let's multiply these numbers here and these here. So I've got 2 times the cube root of 2 minus 15 times the cube root of 2 plus 4 times the cube root of 5. Okay, now notice what you have here. You have two values that have like terms. Let's combine those. This one is not a like term. Okay, because this is the cube root of 2, this is the cube root of 5. What's underneath the radical is different. Okay, so let's do this. Let's do 2 minus 15, which gives me negative 13 cube root of 2 plus 4 times the cube root of 5. Guys, we're going to leave it like that. That is done. We cannot combine that any further. Okay, and that's what we've got. All right. So that's what we're doing. We're just adding and subtracting, radical expressions. They can be very easy, okay, but you want to be able to simplify these and get them down to a usable form so that you can combine them. Okay, now what I'm going to do over on A through D is I'm going to multiply, perform the operations, and then simplify if we can. All right, so what I'm going to do is this. I'm going to go ahead and distribute square root of 5 into this. Okay, so what this is going to look like, this is going to be the square root of 5 times the square root of 6 minus the square root of 5 times the square root of 10. All right, and so what I end up getting here, square root of 5 times the square root of 6 is going to give me the square root of 30 minus the square root of 50. So as I look at these numbers, I want to try to combine them. All right, but if I've got the square root of 30, all right, there's no perfect square that divides into 30. Okay, my perfect squares, remember, are 4, 9, 16, 25. None of those are going to divide into 30. However, 25 divides into the square root of 50. So let's simplify this at least, and let's do the square root of 30 minus the square root of 25 times the square root of 2. All right, and so what we end up getting here as a final answer is the square root of 30 minus square root of 25 is going to give me 5, and then times the square root of 2. All right, and that's that. Okay, that's my answer. So you want to simplify it as much as you can, but if you don't have like radicals, then you don't have like radicals, and that's okay. All right, now over here, on part B, you're being asked to multiply these. Now, these are in the form of binomials. And guess what we get to do, folks? We get to FOIL this. Okay, now you can also use the box method. Okay, so if let's FOIL it first. We should get the same thing. Let me do 3 times 8. So that's going to give me 24. First, outside. So let's do 8 times 2 times the square root of 7. So that's going to give me plus, now 8 times 2 times the square root of 7 is going to give me 16 square root of 7. Okay, and then the inside terms are going to give me minus 3 times the square root of 7. And then my last terms is going to give me minus 2 times the square root of 7 times the square root of 7. Okay, now let's do the next step. Let's combine our like terms. All right, so I've got 24, and actually let's do this. Let's do plus 16 square root of 7 minus 3 square root of 7 minus 2 times the square root of 49. Okay, now the square root of 49, I can evaluate that. All right, that's 7. So I've got 24 plus 16 square root of 7 minus 3 times the square root of 7 minus 2 times 7. Okay, so now, all right, what we do is let's combine our like terms. Now, I can combine 24, actually, no, let's do this. I can combine 16 square root of 7 and minus 3 square root of 7. So I get 24 plus 16 minus 3 is 13. So this is 13 square root of 7. And then minus 2 times 7, which is 14. Okay. Now, my like terms here, 24 minus 14. And that's just going to give me 10. So I've got 10 plus 13 times the square root of 7. And that's my answer. Okay. And that's all we're doing. All right. Now, if we did the box method, okay, let's do the box method. Let's draw our box. Okay, and so I've got, what is it, 8 minus square root of 7. So 8 minus square root of 7 up top. Down below, 3 plus 2 square root of 7. Okay, and you can do whatever you want. Okay, either one of these works. 3 times 8, 24. Minus 3 square root of 7. 16 square root of 7. And then 2... Negative 2 square root of 7 times the square root of 7 is square root of 49. So then if I add these together, you know, we get the same thing. 24 minus 3 root 7 plus 16 root 7 minus 2 times square root of 49, which is 7. So you get 24 negative, these are like terms, so you're going to get plus 13 root 7 and then minus 14. So 24 minus 14 gives us 10. So I've got 10 plus 13 root 7, which is the same thing we got. So whichever one you want to do. I typically, you know, I don't usually, when I multiply, you know, binomials that contain radicals, I tend to use the FOIL method a little bit more than, say, the box method. You know, either one works. Doesn't matter. Okay. Now this one's interesting. Okay. What I want you to notice about part C is that you've got 3 times the square root of 5 plus 4 times the square root of 3. Okay, that's one quantity, that's one binomial. Here, you've got 3 square root of 5 minus 4 square root of 3. Now, I want to see what we get out of this. All right, I'm going to use the FOIL method. So I'm going to take 3 root 5 times 3 square root of 5, so that's going to give me, let's just write it all out. 3 square root of 5 times 3 square root of 5. Okay, my outside terms is going to be minus 3 root 5 times 4 root 3. Inside terms is going to be plus 3 root 5 times 4 square root of 3. And then my last terms is going to be minus 4 root 3 times 4 root 3. Okay, now from here, let's think about what we got. All right, I'm going to do 3 times 3, which gives me 9. Square root of 5 times the square root of 5 gives me the square root of 25. Okay, now minus, okay, 3 times 4 is 12. Square root of 5 times the square root of 3 is the square root of 15. Okay, if I do 3 times 4 here, so I get plus 12 times the square root, 5 times 3 is 15. And then over here, we're going to do minus 4 times 4, which is 16, times the square root of 9. Square root of 3 times the square root of 3. Interesting. Okay, so now check this out. All right, I've got 9 times the square root of 25. Okay, let's take the square root of that. This is going to give me 9 times 5 minus 12. Wait a minute. These are like terms here. Negative 12 square root of 15 plus 12 square root of 15. Those guys, these are going to add to 0. So I'm going to do a plus 0 here. Those cancel out. Okay, that's really nice because over here, look what I've got. I've got 16 times the square root of 9, which is 3. Guys, look what's happened. Okay, these, all the radicals are gone. Okay, this is really important. All right, that we see that. Okay, because this is going to be something that we're going to use in the future. Okay, in the later part of this unit. So let's continue this. All right, so I got 9 times 5, that's 45, minus 16 times 3, which is going to give me 48. So I've got 45 minus 48, which gives me negative 3. Guys, look what we just did. That's pretty crazy. And that's a big thing, okay? Notice how, these were pretty much the same thing except for one where we were adding, one we were subtracting. It's kind of like that difference of squares thing, I remember. Interesting. Okay, now over here, let's take a look at part D. Now, if I've got something squared, what I'm really doing is I'm taking the quantity 3 square root of x plus the square root of y and multiplying it by itself. 3 square root of x plus the square root of y. Okay, and so what I've got from here is, let's go ahead and multiply this out. So I've got 3 times the square root of x times 3 square root of x. Okay, to my outside term, so I've got plus 3 square root of x times the square root of y. My inside terms, I'm going to do plus 3 square root of x times the square root of y. And then my last terms, we're going to do plus square root of y times the square root of y. All right, so once I do that, okay, what I want to do is this. I'm going to multiply them together. So I've got 3 times 3, which is 9, times square root of x times the square root of x is the square root of x squared. Okay, now what I'm going to do here is I'm going to combine these. Okay, we're going to have like terms here. I'm going to do plus 3 times the square root of xy plus 3 times the square root of xy. And then plus square root of y times the square root of y is going to give me square root of y squared. Okay, so now, all right, I got 9 times the square root of x squared. Now I could take the square root of x squared, so I'm just going to get 9x out of that. Plus, now these are like radicals here in the middle, so I can combine those, and that's going to give me 6 times the square root of xy. And then plus square root of y squared is just going to give me y. And that's what we're going to get. Okay, so that's the idea. All right, so we're just, operating with these radicals. Okay, so we can add, we can subtract, we can multiply, and guess what? We can divide. So let's take a look at dividing, okay? And what we're really going to be doing here is rationalizing the denominators, okay? And so we have this thing called a conjugate, okay? A conjugate is when you have, for example, the square root of a plus b. The conjugate would be square root of a minus b, all right? So let's do this. Let's remember what difference of squares is. So difference of squares. All right. So with this idea, when you're multiplying, let's just do one like x plus 3 times x minus 3. These are conjugates of each other, okay? And when you have conjugates and you multiply them together, remember what happens. The middle term is going to cancel out, okay? So if I do x times x, we get x squared. I'm going to do plus 3x, I'm going to do minus 3x, and then minus 9. Okay, 3 times 3 is 9. Okay, and what happens is your middle term is going to cancel out. Okay, and that's just going to add to 0, so you just have x squared minus 9. Okay, and you can remember that this is in the form x squared minus 3 squared. Okay, what we are doing is the exact same thing, but using them with radicals. Okay. And so let's just jump in and think about what happens, okay, over here, and let's rationalize this denominator. Now, what I want to do is since I'm adding and subtracting 2 radicals, okay, I'm going to multiply by the conjugate. So I'm going to put that in parentheses. I'm going to multiply this by the square root of 7 minus the square root of 6 on the top and on the bottom. So this is going to be the square root of 7 minus the square root of 6. All right, so that's what I've got. And if I've got 2 fractions, remember I'm just multiplying the numerator, multiplying the denominator, okay? So up top, I'm going to get the square root of 6 times square root of 7 minus the square root of 6, okay? And down below, okay, let's multiply these together. And I'm just going to write it out, square root of 7 plus the square root of 6 times the square root of 7 minus the square root of 6. Okay, now let's do this. I'm going to do the numerator first. Okay, so that's going to give me, distribute this guy, that's going to give me the square root of 42 minus the square root of 36. Okay, now in the bottom, I have to FOIL this, okay? So I've got square root of 7 times square root of 7. That's going to, and let's just write that out, square root of 49, okay? Square root of 7 times negative square root of 6 gives me minus the square root of 42, okay? If I do the square root of 6 times the square root of 7, that's going to give me plus the square root of 42. Notice how these two terms are the same and they're opposites, okay? And then the last one, we're going to do minus the square root of 36, okay? Now, let's think about this for a second, all right? These terms here are going to cancel out, all right, to 0. So let's write that next step. So I've got square root of 42 minus the square root of 36 over the square root of 49 minus the square root of 36. Okay, so now some of these I can evaluate, all right? And so what I would do, my next step, okay, I would get the square root of 42 minus 6, okay? Square root of 36 is 6. Now down here, I'm going to get square root of 49, which is 7, minus the square root of 36, which is 6. So look what I've got, all right? I end up getting that I've got the square root of 42 minus 6 all over 7 minus 6, which is 1. So my answer that we're going to get is the square root of 42 minus 6. Okay? And I can't evaluate the square root of 42, unfortunately. Yeah, we don't have anything that's going to divide into 42 evenly. That's a perfect square. So that's my answer. Okay? And what we've done, like we were doing in the other one, we got rid of the radicals in our denominator, okay? And that's what rationalizing the denominator means, okay? And that's it. Okay, now let's also think about this. All right, remember this example up here. Remember that if I take, you know, the conjugates and multiply them together like we did in difference of squares, I get the first term squared minus the last term squared. So going through all this work, you know, is necessary for understanding. However, if you know the formula, and let's think about multiplying, let's just do square root of 7 plus the square root of 6 times the square root of 7 minus the square root of 6, okay? Based on what we know from difference of squares, remember, I could take the square root of 7 and square it minus the square root of 6 squared. Well, let's think about it. If I take a square root and I square it, that's just going to undo the square root, and I'm just going to be left with what I have, which is 7. Same thing over here. Square root of 6 squared is just going to get rid of the square root, left with what's underneath. And 7 minus 6 is 1. And guys, that's what we got in our denominator. So you don't have to go through all this multiplication to get at what you need, okay, which is kind of cool, all right? So let's try that with the bottom ones, okay? So let's do, you know, okay, so I've got a square root down here, okay, and we're adding and subtracting it, so I need to multiply this by the conjugate. Now the conjugate here is going to be the square root of x plus 2, okay, on the top and bottom, all right? This is going to be the square root of x plus 2, all right? So up top, I've just got 1 times the square root of x plus 2, and on the bottom, okay, I've got the square root of x minus 2 times the square root of x plus 2. All right, and so, you know, if you want to multiply all that stuff out, you know, together, you can, but let's just use what we know, all right? Let's do up top, we've got square root of, all that times 1 is just going to be itself, so square root of x plus 2 over the first term, square root of x squared, minus the last term, which is 2 squared. Okay, so watch what happens. All right, we're going to get square root of x plus 2 up top divided by square root of x all squared is just x, and then minus 4. And that's my answer. Okay, I don't have any more radicals in my denominator, and I can't divide anything out from here. Okay, so that's all we're left with. All right, let's take a look at the last one. Okay. On part C, you know, let's multiply by the conjugate. If my denominator is x minus 2 times the square root of y, all right, let's multiply that by x plus 2 times the square root of y. Up here too, x plus 2 square root of y. All right. Now, the numerator we will have to multiply out. We will have to FOIL that, but the denominator not so much. Okay. So let's do that. Let's go ahead and FOIL this out. So I've got x times x, so we get x squared. Okay. 2 square root of y times x, so I'm going to do 2 times the square root of y times x. My last terms, 2 square root of y times x, and then my last terms. All right, so I've got plus 2 square root of y times 2 square root of y. Okay, now in my denominator, let's use our formula for difference of squares. Okay, so what I end up getting is I get my first term squared, okay, minus my last terms, 2 square root of y all squared. Okay, now let's take a look at what we get. Okay, up top, all right, we get x squared plus, I've got 2x square root of y plus 2x square root of y plus 2 times 2 gives me 4, and then square root of y times the square root of y is square root of y squared, which is just y. Okay, and then, all right, down below I've got this. I've got x squared minus 2 squared gives me 4. Square root of y squared just gives me y. Okay, and that's it. All right, now we can simplify the top and combine these like terms here and here. But look what we get. All right, I'm going to get x squared plus 2x gives me 4x. Okay, square root of y plus 4y, and this is all being divided by x squared minus 4y. And that's it, and that's all we're doing. Okay, notice how I don't have any more square roots in my denominator. All right, and that's the whole point. Okay, so, you know, pretty simple if you remember difference of squares, but, you know, there is a lot of, you know, steps involved. Might be a little confusing, but guys, take your time, practice, okay? Swing by office hours. Let me know if you have any questions. That's it for 7.5. Talk to you soon. See you. Bye.